Hyungki Kim, and I'm a I will present about introduction to TensorFlow. Professor made this invited presentation for you to study about how to use TensorFlow in practice. And I'm currently working in ADD, which is Agency for Defense Development in Korea. Okay, so about this presentation, most of the materials in this presentation is from the deep learning zero tool made by Sung Kim, who works in another country. I don't know him, but I found this material on the internet. Most of the slides and the source codes can be downloaded from here. And there are some presentations made by him, and you can see that in the YouTube. But I'm sorry that the contents of this link is presented in Korean, so you may find it's okay just to see the source codes to study the contents. And there are two very nice courses in Coursera. Have you heard about the Coursera? You can see that you can attend the class in Coursera to learn the deep learning and machine learning. And these two classes are presented by Professor Andrew Ng, who is one of the most famous professor in the deep learning field. Okay, and I think Professor already has covered a little about the TensorFlow, I think. And the definition about the TensorFlow is an open source software library for numerical computation using data flow graph like this. And in this graph, nodes represent mathematical operation, and the edge represent the array data, which they call tensor, and the communication between them. But you don't have to care about this definition. I think it is okay to just know how to use it in practice. And the TensorFlow can be used using Python, Java, C, and Go language. But I believe the Python is their major programming language. So maybe you should study a little about Python to implement something you want to make. And I think Professor selected TensorFlow because of this. You can see the list of deep learning or machine learning libraries made with open source. And you can see that the TensorFlow has most frequently used by a lot of by researchers. So I think in the early days of the machine learning, the Cafe and Theano and Torch is the three most famous, well-known deep learning libraries. But after Google made TensorFlow, everybody used TensorFlow. So it is better to use it. Yeah. Okay, so if you have a notebook, you can follow the installation guide I made. And okay, so if you want to use TensorFlow, you have to install some things in your development environment. And there are a lot of ways to do it. And my recommended way is this. First, make virtual environment, development environment using Anaconda, and online install the TensorFlow in CPU version, and develop using Spider or Jupyter Notebook. And this kind of installation is most robust way to install that I found, and it is very easy to install. And also, if you want to implement something in your own, please feel free to install TensorFlow GPU version. And if you want to implement it in GPU version, you need NVIDIA VGA in your machine, and you have to install CUDA toolkit and CUDNN first in your computer. And so, if you visit this website, you can see the page. I captured it below, and you have to download version of Python 3.5, I think. So you can download it in there. And if you after installing the Anaconda, you can see that icons will appear in your desktop, and you can run this Anaconda prompt and make TensorFlow environment by following the process written in the right picture. And yeah, so the Anaconda will be used to make virtual development environment. So if you have an experience with other programming language or applications, it does not usually make the environment of development for each session, but using Anaconda or Python, you can make separate development environment for TensorFlow or another programming language or another application. So it is easy to maintain the development environment using Anaconda. And yeah, just follow the process, and there will be no problem. And if you want to make sure you have installed it properly, you can check if the environment was generated by using the Anaconda navigator. In the right picture, you can see that there are second tab named environments, and there should be the TensorFlow in there. And if there is TensorFlow, then it is okay to use TensorFlow in your machine. And okay, so this is about installation. Do you have any question? Okay. Then, as I mentioned, there are two IDEs for TensorFlow or Python you can use by installing Anaconda. The two is Jupyter Notebook and Spider. And I will talk about how to run Jupyter Notebook and check if TensorFlow is installed properly. And if you have a Jupyter Notebook and TensorFlow icon, like the below red rectangle, if you have an icon of it, just click it, and you can see the Jupyter Notebook will be opened in your web browser. And I found that sometimes it does not automatically made icons for you. Then you have to run it by using Anaconda prompt. And there are two lines of two lines of command you have to input to run the Jupyter Notebook, which is activate TensorFlow and type Jupyter Notebook. Then it will appear. Okay.
Any version of Anaconda is okay?
Uh,
I choose specific version.
I don't know. I always install the latest version, and there is no problem, unless if you install the Python version above 3.5. Oh, okay. So if you if you see the Jupyter Notebook in your computer, you can test if TensorFlow is properly installed for you. And there are new icon in the Jupyter Notebook, and click Python 3, and you can type these 4 simple test codes, and if you run it by typing Shift Enter, then you can see this hello TensorFlow string is printed in your computer. So I hope I can show you. Okay, like this, the web browser will be automatically opened, and okay, you can make a new code by clicking New and Python 3, and yeah. So if the string comes out, it is okay to use Jupyter Notebook. And if you not like this, you can use Spider, which is more like Visual Studio or Eclipse, like other IDE. And the running process is similar. You can just click Spider, TensorFlow icon, or use console if it does not work well. And you can use the same test code for check if TensorFlow is properly installed in your virtual environment. Yeah. So the installation and running process for development is like this. Do you have any questions so far? Okay. The other parts of my presentation is the implementation part, Uh, but I think it is not possible to explain everything in about 60 minutes for you. So you may have to study many things by your own to do the project of this class. But I selected some important parts that I believe it is important, and I will briefly show you and explain about how it is working. And, um, and as I mentioned, the TensorFlow is designed using graph, but as I mentioned, it is not important to know if it is graph or it has some other structure, but they already said that it is the graph-like computational structure they designed. And the first thing you have to know is that every uh, every variable in TensorFlow does not work at, before you run the session. For example, like this, you can see that node 1, we assigned it as 3.0, and node 2, we assigned it as 4, and node 3 to add node 1 and node 2. So if you are familiar with other programming language, if you print the nodes, you expect to see the value 3, 4, and 7, but it does not. TensorFlow calculates everything when you run the session. So you can see in the below in the line 6, you have to make session first, and you run that node in the session. Then it will make a value for the variables. So if you run it with session, you can see the values 3.0, 4.0, and 7.0 is printed. So this is the most important part you have to understand. If you have to make structure or graph first, and then you have to you have to make that graph runs using sessions that run. And then TensorFlow will calculate everything and make an output. So yes, the first part is building graph parts, and if you run the session that run and make feeds of the some nodes, then it will calculate the values. The second thing that is important for your convenience is placeholder, which is, I think it is not usually seen in other programming languages. If you made some variable using as placeholder, you can set the value of that variable in the runtime. So if you can see that in this code, we have made A and B and adder node which adds A and B, but we did not specify what is value of A and value of B. But we set the value of A and B in the session that run code. So this means that you feed the value of the variable in the runtime. So this thing is maybe you don't have to use this for your project, but I believe that it will be easy if you use it properly for your code. Yeah. So unlike the picture before, in the second process, it will feed the value by using the keyword feed dict, which is dictionary, and it feeds the value of the variable in the runtime. And other process is similar. Okay, and the third one is tensor, which is why the TensorFlow is named as TensorFlow. And basically, if you have an experience of using MATLAB, you can understand it easily. So tensor has a rank which is 0 or 1, 2, 3, 4, and to n, which means that if the tensor has rank 0, that it means it's just a single value. And if it is rank 1, it is a vector or arrays of values. And if tensor has a rank 2, it is a matrix. And if a tensor has rank 3, it is, they said it's 3 tensor, or you can understand it just like 3-dimensional array or matrix. Okay, do you have any questions so far? Have anyone have installed TensorFlow? No?
I once tried, but I failed. So,
Did you install the Anaconda?
yes, I followed a similar process like you showed, but I tried.
Ah, okay.
Okay.
Okay. Ask me or Inhwan
Okay.
if you have any problem of installation. Okay. The next part start with the linear regression. If you have heard any class or presentation about deep learning or machine learning, it would always start with the linear regression. And the because it is start with linear regression, because it is the easiest problem that can be solved by TensorFlow or other machine learning libraries. Yes. So the problem is this: is that if you have some value, input value and output value, which is x and y in this equation, you have to estimate this w and b by calculation. And the h of x, which is called hypothesis, is the model that we are expect to estimate the parameters. And we can calculate how well is that model is working by computing this cost function, which is dependent on the parameter w and b. And as you can see, right side of the sigma equation is that if you feed any value of x, it will calculate the h of x, and you will calculate the sum of square of the how it is how much it is wrong with the real value. I mean target value, which is y. And so okay. Okay, so as I mentioned, the model we want to make is wx plus b, And yeah, please see the code that we made some input and output arbitrarily for the test. So we make input as 1, 2, 3, and the correct value, target value is 1, 2, 3. So if you want to make Wx plus b will be fit for that input values, you can easily see that W should be 1 and B should be 0. So Wx plus 1, x plus 0 is same with the y training data. And in the TensorFlow, you should make the value you want to calculate as variable. You can see in the third line, W equals tf dot variable, and you initialize it with random normal value. And this kind of details, I think you should see the code again and again to understand everything. But yes, at first we initialize it as a random value. And the fifth line says that hypothesis is x train dot w plus b. So this is the model that we want to get. And we define the cost. Cost is 1 over m sigma h of x minus y square. And this can be described as a code, as you can see in the below. So yes, so that part is the definition of our problem. And the second important thing about how to solve this problem is about gradient descent. And I think there are a lot of important issues and things you have to know about gradient descent if you really understand what it is doing. But if you use TensorFlow, you don't have to care much about the gradient descent because the programming, the library will do it for you very easily. So just see these two lines of code that we will use the gradient descent optimizer and to reduce the cost of our parameters. And if you run the graph, yeah, it will calculate the values. And the upper part is not the calculation part. The actual calculation is done in session.run, train, and cost W and B. So this is the about linear regression, and yes, this is the code that I showed you, and if you run this code, you can see that as we expected, W should 1, but it is near 1, but has some error. And B should be 0, but it is not exactly 0, but it will find the nearest answers for the parameter. And okay, I have to say this, that the GitHub link that I showed you, you can download all these codes freely. And for this project, I think you don't have to understand everything for this, because I know that you don't have much time to do this project. But I recommend you to use these codes as a template. So just follow, just use most of these codes and feed the data for you, made by you. So usually it works well without any problem. So just switching the data and use the code. And yeah, now I think it will be okay to do it. And if you want to implement further, you can change many of these parts, but yes, I recommend in that way. Okay, and we can change a little about this linear regression by using these placeholders. And in the first code, we explicitly define the value of x train as 1 to 3 and y value for training is 1 to 3. But as I mentioned, we can feed that value in the runtime. So at the first part, we just define this variable x and y as placeholder, and in the for loop, you can see that feed dictionary as x equal 1 to 3 and y equal 1 to 3. So we feed the value for the training in the runtime. So yeah, so you can do that. And the code of that part is like this. You did not feed the value in here, but feed the value in here. And yeah, it works well also. This is not. Okay, this is the answer. And the upper left number 3-2 means that the code of here left 3-2, so you can see the code by yourself. And the second thing I want to talk about is gradient descent. That 3-2 code shows how gradient descent works with short lines of codes. And as you can see, the cost measures how our model is work well with the target value y. And if you see that see the graph, the horizontal axis is value of w, and vertical axis is cost based on w. So that means this graph shows that if w is 1, the cost will be is lowest, so the w should be 1. That is our designated answer. And as I mentioned, these lines of code, gradient descent, will find that minimum values for you, but you can see how this gradient descent works inside of the code by these 4 lines of code. If you know, if you heard about some course related to the optimization or optimization, it is very basic approach to get some result of cost minimization. So you can calculate gradient by the hypothesis function, and yeah, you can do that by your own. I mean, this gradient descent dash manual means this code do the gradient descent by the code that that is in that code, not using the TensorFlow functions. So 3.2, that as you can see, there are no lines for these two. These two are the gradient descent function that is provided by the TensorFlow, but in here we don't have it. These 4 lines of code do the same thing with what TensorFlow did it for you. So you want to see that, you can see that if you want to. Okay, and if you want to use optimizer, you can just use the function that TensorFlow provided. Okay, then do you have any questions so far?
Why do you set learning rate as 0.1?
I think this is like if you learn, if you heard about other machine learning class, this kind of parameter is called hyperparameter that user should set and should provide. And there are a lot of techniques of how to find the right value for that hyperparameter. But it is basically just trial and error if you can get some right result for that learning rate.
But it's fixed value as opposed to the weight and bias that we should train.
Yes, it is for the how fast the value should approach to the minimum. But if that value is too high, it can diverge. So in most cases, learning rate is used 0.1 or 0.01, 0.001, like that. The second code is about the character recognition. There is famous data set which is called MNIST, and yes, there are a bunch of images of the number written by hand, and that represent 0 to 9. And in this problem, we want to recognize what is written in that picture by using TensorFlow. And yes, maybe this part is not closely related with your project, but I think it is very important to understand how to make input data for your own. For here, we have an image written as maybe 4 or 9, and as I mentioned, this kind of handwritten data is stored as the picture. And if you know about how the picture, digital picture is stored, we can, each cell has its value, pixel value. So if let's assume that this picture has no RGB color value, just grayscale, then the white side is valued as 255, and the darker side is near to the pixel value of 0. So we can see that this is a picture, but in computer, this is just a bunch of pixel values, numbers stored in this picture. So in these cases, in most of, to feed this kind of picture data into the TensorFlow or other machine learning libraries, we usually make this image into the single, rank 1 of tensor. So maybe we have a picture that is 3 by 3. Usually we make this into this kind of vector, 9 by 1. So value of here, this pixel goes here, this pixel goes here, this pixel, yeah, here, like this. So yeah, this kind of structure is good for human eyes, but by making this rank 1 vector, it is very easy to feed the data to the learning process. And anyway, it does not lose any data because it all have the 9 pixel value, so there is no problem with it. And yeah, so in this example, they do the same thing by making these 28 by 28 images into the 1.784 sized image. And there is some issues about that non dimension data, but maybe you can see what that means in the code that I will provide. Yeah. So just don't care about that none right now. And yeah, so if you see the MNIST introduction code, if you typed these 2 lines of code, it will automatically download the MNIST dataset in your machine. So I already run this. So this folder and these 4 files are automatically downloaded in your machine. So basically, I skipped this part. Basically, that 4 zipped file is for the training set image and training set labels, test set image, and test set labels. So yeah, as I mentioned, this kind of image is stored in the training set images, and we should feed the value, the right value of that image. So in that picture, if it says picture is like this, we can label it as 0 and 1 as 1. So we first have to feed what is the right value, and we want to test the unknown image and feed it into our code, and if it works well by using the test set images and labels. Yeah, so this code is just for import data. And as I mentioned, the X is the single vector, and Y is the label. So in these cases, number of classes, NB, under my classes is 10, which means that there are only 10 kinds of numbers. I mean, 0 to 9 is 10. 0 to 9 is 10 types of images, so we define that classes as 10. And yeah, so you can define the similar X, Y, WB in these cases. And another thing pops up, which is Softmax. And this is for, if you may heard about the logistic regression. And yeah, so in the first part, I mean the problem that I showed you for X is 1 to 3 and Y is 1 to 3. We want to calculate the W, which has real value. This kind of problem is logistic regression problem. And if you want to check this kind of problem, that means if you feed this picture, it should conclude that it is 0 or 1 or 2. So there is no 1.5 or 0.8. It is only without the discrete values. So this kind of problem is called maybe classification or logistic regression. So in these cases, we need Softmax classifier. So you can see that in that code, the hypothesis uses the Softmax, and yeah, I mean, it is not difficult to understand how Softmax is configured. And yeah, just remember that if you want to solve the problem like that, it is better to use Softmax. And yeah, there are some. Yeah, I think you don't have to know about this epoch and batches. Yeah, just see how it runs. So I added the lines of code that shows what is the input images here. So I will comment it out to not show the image and just see the result. Yeah, so just by feeding a lot of images and the right answers, we can predict another image and says that this picture is true. So maybe this is too short to show you about what is the result, but I intentionally commented some lines from the original source code, but you can see that how it reduces the cost and find the answer if you run the original source code. So yeah, that is how. Yeah, the point is that this 7-4 source code lets you train the image and find out what is the number. And if you want to implement a similar thing in your project, you can refer this code and change it to fit your data. And this is the similar things. And yeah, so do you have any questions so far? Okay. The second part is maybe you have heard frequently. That is the neural network. So until now, that every code uses this somewhat later, but you can see that W and B is defined in the first and second line. So we only use one parameters. And the advantage of using neural network is you can expand it to the layers. So there are a lot of parameters. So you can see that there are three big parameters we are using: W1, W2, and W3. So it is not easy to how it works in this class, but you just can imagine that there are more parameters in the model, so it may be more accurately predict the model. So if you want to solve the problem by using neural network, you can see that the source code 10-2, and it is not it is not hard to make the codes with the neural network. You just add W2, B2, L2, and W3 and B3 instead of just using W and B. And other parts will be the same. And yeah, you can see that by comparing 10-1 and 10-2, you can see that accuracy increases 4% from 90.35 to 94.55. Yeah. So using neural network is better. So the last part I want to show you is that that I made yesterday, which you may refer to use your own data for the project. I mean, the problem I made is that there are two kinds of images. These are the pictures that I made by getting the CAD model. I made the images from a lot of point of view. This model is the air compressor, and the second model is ANC 101. The model looks like this. So in this problem, I'm classifying that this model is first model and this model is second model. And if I fit these two images, I expect that my program can classify, okay, this is the first model and this is the second model. And the code I made is like this. So I did not configure the neural network because the problem is very easy. So I don't have to use neural network. But yes, I want to explain the brief process of my code. That as you can see, the first images are in the D drive, image, and array folder. So I first made a list of the image files in that folder, and that is folder A and files A, and also defines the second model images in folder B and files B. And by using this library, which is PLT, you can read the image very easily by feeding the file name of that image. And then, as I mentioned, the original image in the folder is 128 by 128. So I can make, I typed reshape to make this two-dimensional image data into one-dimensional, and save it in the X data and Y data. Also, the second model's image to the same matrix. And do the same thing with the RQ, which is I want to query and test if we can classify this new image. I mean, you can see that this is the image that I want to know if it is air compressor or ANC 101, and you can see that there is no exactly same images in the database. I mean, this is somewhat similar, but as you can see, the angle of view is little different. So this is new image that does not exist in the database. And if I made that kind of X data and Y data, I just dive into the TensorFlow model, just use W and B and make Softmax classifier to train the data. And yeah, I found that it works well to classify the data. If database is big, it is not easy to see that accuracy goes up to 100%, but I think it is rather small data set, so the accuracy goes up to the 100%. And okay, so these are the truth classification, that the first file is the first model, second image file is first model, and third image file is second model, fourth image file is second model. So I just outputting the 0 and 1 if the images are classified to the first class or second class. First class is air compressor, and second class is ANC 101. And this first matrix is the truth value, and this second matrix is the prediction that we have made. So if you closely see that these two matrices, the matrix is the same. That means this prediction, this W and B, is succeeded to make everything right. And these two lines of codes is for this RQ data, which does not exist in the database. So these two images, the true value of these two images, first class and second class, and the predicted value is first class and second class. So yeah, it just done well for my problem. And also, yes, you can see that there is a lot of materials you can learn from this data set. And I don't know how much our professor will cover the theoretical backgrounds of the machine learning and deep learning, but because TensorFlow is very very easy to understand, I think, because the lines of code is not that long. So you may see that by your eyes or change some parameters to see how it works to implement it by your own. And I think there are two more important theories to apply the machine learning or deep learning into your actual problem. The two things is the CNN and RNN, which is convolutional neural network, and recurrent neural network, which is two big models that recently used for many research fields. And I think, I mean, in this presentation, I decided not to explain it because I cannot fully cover about CNN or RNN in the limited time, and I also cannot say that I completely understand that concept. But as you can see, there is some examples about CNN, which is lab 11, and there are examples about RNN in lab 12. So again, you can refer their codes and feed your data to train your own data using CNN or RNN to make something valuable by your own. Okay, this is the end of my presentation, and if you want to ask something to me, please email to there. And I think maybe the TA has also a lot of experience about TensorFlow, so you may ask him about how to do something with the TensorFlow. Okay, do you have any other questions for TensorFlow? Okay, let's finish this. 그러니까 엠니스트를 가지고 CNN으로도 풀고.
이거는 그냥
어떤 거? 지금 내가 한 거 아니면은? 지금 한 거? 지금 한 거, 그러니까 엠니스트는 데이터셋 이름이고, 그러니까 그거를 지금 이제 이 예제 보면은 처음에는 이제 그냥 그냥 리그레션 가지고 푼 코드가 있고, 뉴럴 네트워크 가지고 한 게 있고, CNN 가지고 한 게 있는데, 나는 첫 번째 방향 제일 쉬운 거 가지고. 아니, 뉴럴 네트 안 썼어. 그러니까 W하고 B가 하나만 있는 거는 뉴럴 넷을 안 쓴 거지. 그러니까 W가 여러 개 있어야 뉴럴 넷을 쓴 건데. 근데 이제 두 개밖에 없으니까 그거를 굳이 쓸 필요가 없어서 간단하게.